So this work was started by Bill McKinnon back in the late 80s. Like all good research, it began with disagreement. Bill didn't agree with many of the views about visual muscling held by the scientific community and by industry, and he set about proving that his views were right. Some of the questions that Bill wanted to see answered were whether it was possible to increase muscling in British bred herds using visual muscle score. So we know we could do that by crossbreeding with a high muscled breed, but this research is really to see whether it could be done without using that avenue. He wanted to see what the benefits would be of improving muscling in such a herd and whether there are any drawbacks to the way that the cow herd functioned. So the herd's a predominantly Angus herd, which has been divergently selected from 1992 until currently into low and high muscling lines based on visual muscling or muscle score. So before we get any further, what do we mean by muscle score? What it is a visual assessment of the thickness and convexity of an animal independent of its fatness and size. Bill's prime fact, which is referenced down the bottom of the slide, describes how this is assessed in more detail. But basically, animals are scored from a very low muscled E through to a very well muscled A. Many of you will be familiar with muscle scoring. It's used by the National Livestock Reporting System to describe animals, and it's used in bull catalogues and things like that. How this might look like in real life, and these are two steers from the muscling herd, with obviously the guy on the right being a very low muscled steer in the E category, and the guy on the left being a very well muscled steer in the A category. So within our muscling herd, we capture most of the range of that muscle score system. So what always happens in terms of bulls from the herd is that they're purchased from industry each year based on their muscle score, and about 70 bulls have been represented in the herd to date. So this means that it's not a closed herd, which keeps it relevant to industry. About 10 years ago, a myostatin mutation appeared in the high muscled line, and this was retained in the herd to have a line which had one copy of that gene. So we have low muscled animals, high muscled animals, and then high muscled animals which also have one copy of that myostatin mutation, giving them some extra muscling. The herd is fully pedigreed and breed plan recorded, which makes it even more valuable for research. So just to show you what the cows in the line look like, we just have 3 volunteers, one from each of the lines, and you'll see that, and they're in pretty good condition, so it's not, they're not skinny or whatever, but you can see that low cow, she's pretty low muscled, not a lot of just by muscling. The high cow is better, she's got a bit more thickness to her, and the myostatin cow is more muscled again. It is important to note that although she's well muscled, that the myostatin cow is not double muscled. Yeah, they're not extreme, sort of like Belgian blues, but there's definitely a big range in muscling across the 3 lines. So what I wanted to do was give you a bit of a summary of the types of data that have been collected on the herd, so that if you have questions about specific things, you know what we have information on. So maternal productivity, right from 1992 to current, we've been collecting information on matings, pregnancy, calving difficulties, calving success in cows and heifers, so that performance of each of those lines can be calculated. On the progeny, we've collected birth data. We've got about 3,800 records now on calves, weights, body shape, etc. At birth. We've taken quite a lot of measurements of body composition, growth rates, weights, hip height, muscle score obviously, from weaning through to mature cows. We've got about 3,500 weaning records now, about 2,000 yearlings. We can't keep all of our animals past weaning. We just don't have enough room. And we've had about 600 animals go through the feedlot, so we've got some indication of how they grow and their composition in that environment, and collected a lot of data on our mature cows up to about 12 years of age. We've been myostatin genotyping the herd since the test became available in about 2005. We've got about 2,500 records on that for now. The steers that we put in the feedlot, we've collected feed efficiency in the research feedlot out at Toowoomba. Got about 300 records on that now. And obviously carcass data is a big focus on a muscling herd. We've got about 1,000 records on carcass data, MSA grading, etc. We've done about 400 animals on retail meat yield, so an actual bone-out measurement of retail meat yield, and done meat quality on about 100 animals. So that's objective and sensory testing. So obviously the numbers of data that we have in the younger ages are a lot higher than what we've got later on in life, where this work's been funded by MLA funding. So the data has been put into pre-plan from the beginning of the herd until current, and thanks in large part to various postgrad students, a fair bit of other science has been done on the herd as we've gone along. We've looked at temperament, stress physiology, some glycogen, some metabolomics, some gene expression, phenotyping, etc. So there's a few bits of interesting information going around about some of the differences that muscling can cause. So the herd itself has travelled a little bit. So they spent the first good proportion of their life at EMAI, and then since then they've lived at Grafton and Glen Innes. So the results that we have them living in a range of climates and under a range of nutrition. During most of it, they haven't really had any special treatment, although the nutrition that they have at Glen Innes now is the best that they've sort of been on in the life of the herd. And a lot of helpers have been involved in the herd along the way, a lot of staff at those stations. We actually did, as a part of an MLA project, run the herd on poor nutrition for about 3 years to see if a difference in performance of the cow lines would appear. And in this situation, they lost about 150 kilos of body weight, so they really did challenge them. And during that period of time, the cows were ultrasound scanned and muscle scored 4 or 5 times a year to really have a look at what their body composition was doing through that weight loss and gain. Okay, so with no tables and a very brief summary of the findings, some of the key findings that we have had are that so if I look at it in terms of increasing muscling in the herd, we found that did not change the weight or growth rates of the animals at any stage of life, birth, weaning, yearling, in the feedlot or in mature animals. Generally, as muscling increases, the animals do carry a little less fat, but this difference has varied a bit over time. Also, with increasing muscling, the hip height is reduced slightly. So we get a difference of a couple of centimetres, about 2 centimetres between the lows and the myostatin animals. The steers that we've measured feed efficiency on at the feedlot have shown us that with increased muscling, the net feed intake or feed efficiency improves, and this has been due to animals, the higher muscled animals, eating less for the same growth rate as what the low muscled animals did. And this is kind of logical because the higher muscled animals are putting on a greater proportion of lean tissue than what the low muscled animals are. But in terms of our carcasses, we've found that with increased muscling, dressing percentage increases, and this has been at about 0.8 of a percentage unit per full muscle score class increase. And this is a benefit that's returned directly to the farmer. So your carcass weight, if you're selling to the abattoir, will be higher. Also, we found that with increased muscling, you get an increase in retail meat yield, up to about a bit over 1% each unit per muscle score increase, and an improvement in the meat to bone ratio. This is this means that it's more efficient for processing of those animals. You get more meat from the same animal, and it's if processors start paying on retail meat yield, this could be another benefit that gets paid straight back to producers. In the animals that we've done meat quality on, we've found no difference in meat quality across the 3 lines, and they've all had good meat quality. We do find that there is a reduction in marbling in the myostatin animals, but this hasn't been high enough for taste testers in the sensory testing to assess it as less favourable. So it's definitely something that's there, but it's not, in these animals it didn't cause a significant drop in the favourability or the likability of the meat. So we found no difference in maternal productivity in the 3 lines across the 20 years that we've analysed. And this is sort of, we looked at this in a few different ways, kilograms of calf wean per cow joined, etc. And basically there's no differences really came out. The only real exception to that is when we ran them on the very poor nutrition for 3 years. All 3 cow lines did drop in fertility in that instance, where they were, after 2 years, when they were 150 kilograms lighter. But the myostatin cows did show a significantly lower calving rate than the other 2 lines. So there was some difference there on that long-term low nutrition, and that's the only difference that we've managed to come across today. So we have a large enough data set now that we've been able to run some genetic analyses on muscle score, particularly using our weaning and yearling traits where the numbers of animals are greater. And what we've been able to show, and I don't think it's really been shown anywhere else, is that muscle score does have a moderate to high heritability, particularly if it's measured by someone that knows what they're doing. And it also has a low genetic and phenotypic correlation with the weight and fatness traits. And that's important because it means that you can select for better muscling in your herd without automatically changing your weight and your fatness. They might be things that you don't want to mess with. This analysis also showed that eye muscle area was correlated to muscle score, but it didn't come out as being the same trait. And this is important for systems which utilise eye muscle area as a proxy measure of muscling, just to be aware that they're not similar enough to be considered the same trait. We also found in that genetic analysis that there are very high genetic correlations between weaning and yearling muscle scores, and this indicates that you can select animals at a young age, and you're going to know what you're going to get at the end. You don't have to wait around before you do any selection. So the crux of it really, why does muscling matter? And it's really, the point of selecting for better muscling is really to increase your saleable meat yield. We're breeding beef animals, we're trying to produce meat, and this slide just shows an example of a couple of steers that we killed a couple of years back. The one on the right is in the E category, the one on the left is in the A category. You can see the difference in the shape of the carcass. Interestingly, these 2 steers were different live weights at slaughter. This one was about 30 kilos heavier. With the improved dressing percentage, they came out to have the same carcass weight, so it's the same return to the farmer from a lighter animal which has eaten less to go to that stage in this guy's case, and also his retail beef yield was 4 percentage units higher. So, the abattoir, or perhaps in future the producer, is getting paid more for that because it's generated more retail meat, more usable product. And these dressing percent and saleable meat yield, they're very strong beef industry profit drivers, and they're a major part of all Australian or Angus selection indexes, so they know how important these traits are. So if we look back at the questions that Bill had, have we answered them? Is it possible to increase the muscling in British bred herds using a visual muscle score? Yes, it is, with reliable assessment, or ideally, considering we can't have a country full of Bill McKinnons, an objective method to measure muscle score. What are the benefits if you do increase your British bred herd's muscling? You can get a higher carcass dressing percent, a better retail meat yield with adequate fatness, good meat quality, improved feedlot efficiency, price premiums, which I hadn't sort of mentioned before, but through the sale yards you get about a 14 to 20 cent kilogram premium for each increase in muscle score. Improve gross margin, and you maintain your productive cows. Are there any drawbacks? Well, not really, not that we've found. The only qualification of that might be for people that want to use that myostatin gene for an extra kick of muscling, which people do use that in industry. You might want to keep them on reasonable nutrition to get the benefit out of that, or just be aware that if conditions get really tough, they might drop in their fertility a bit more than your lower muscle cows would. So just some additional things that we've been doing with the herd. Having a herd divergent in musling's been useful for some of our other DPI projects, and we've been collaborating with other researchers, Malcolm McPhee and Brad Wansley in this area, to help provide more data for further development of beef specs. Having that divergence really allows that modelling to go across a wider range of animals. And similarly for the development of the 3D cameras, the herd with the original group that Malcolm's been using to develop the 3D cameras to particularly see whether we can get an objective measure of this muscle score, and having animals that have a range of muscle scores is not a bad place to start when you're trying to develop something like that. And this could be a very, very, very useful tool moving into the future, getting some objective measurements of muscle score and other measurements. And it may even allow us to talk about putting muscle score into breed plan, maybe as part of the retail beef yield, EBV, or something like that, if we can get those objective measures going. So currently for the last couple of years, the herd's been in the Angus side benchmarking project, and the purpose of joining this was to generate stronger genetic links to industry, with the view being that this would make the progeny more valuable for research, but also a lot of valuable data that fits with our research objectives is collected in that side benchmarking project. And sort of an offshoot from that has been that I think we've pretty much been approved funding to collect retail beef yield on about 1,000 animals over the next few years, and these will mostly be steers from the muscling herd and DPI trangy herds. And that data will be really important for our research, because it'll give us enough numbers to look at some of the genetic things that are happening around some of the carcass measurements, which we haven't got enough data from our herd, and also test the measurements that we've found and the results that we've found in the muscling herd in a broader range of cattle.